This time we're doing 37.12, and it says that a scientist sees that a particle or some kind of wave is made 45 kilometers up into the atmosphere, and then we're doing the let's see, doing the distance one, not length contraction, just distance. Okay, and that's equal to the speed that the particle is going, which I have written above me, but I'm just going to write it again, times c, and then times the change of time. And we're trying to find the change of time because we want to know, as measured by the scientist, how much time does it take the particle to travel the 45 kilometers. So if we just take this and do 45 divided by all of that, we get that the time that the scientist observes is 1.50 times 10 to the negative 4 seconds. And then the second part of it, I think it's asking, use the length contraction formula to calculate the distance from where the particle is created to the surface of the Earth measured in the particle's reference frame. So this time we're going to we're using the length contraction formula, and we're going to do that delta L, which is going to give us the particle's reference frame, I guess. That's equal to the 45 kilometers, or what did I have too many? 45,000 meters that it travels through the atmosphere. Then that is multiplied by 1 minus its speed, which it's given up here, 99540. And once again, the c's are just going to cancel out, so I'm just going to leave it like this. Now it just kind of looks awkward and high, so go like that. Wait, I don't think that would actually work. No, it doesn't work this time. I have no idea. Anyways, when we calculate that out, we get that our length contraction is going to be 43.11 meters, and that's observed as from the particle's point of view, which I think is right, but I don't really know. Then for the last part of this one, it wants us to use two different formulas to find the amount of time that it takes the particle to get down to the Earth. Yeah. So we're going to use the distance formula one. So we're going to use the 43. Let's see how many. Oh, sorry, I messed up my numbers. So 4300. Okay, I just rounded. And that is equal to the change in time times how fast the particle was moving, which again is our u up here, 540 c. So then we just take 4300, divide it by that, and the change of time that we see that the particle goes through is 1.44 times 10 to the negative 5 seconds. So that's the first way that it does it. Then we're going to actually use the time dilation equation. We're going to say, so now we're looking for delta T naught, because that's going to be in the particle's frame. So delta T that we are given is 1.50 times 10 to the negative 4. That's equal to delta T naught, which is what we're solving for, divided by this thingy, 540. Then we just multiply them, and we get that, surprise, it's the exact same time as the one we calculated right here. So since those are the same, that means that we probably did something right. So that's the answer.